cubed over a plus h minus a.
Okay.
Right? And a is 5. Where a is equal to 5 because that's our point of interest. So I have 5 plus h cubed minus 125 over h. Okay? Any questions? All right. Almost done. Okay, so now we're going to give h a value. So we solve for it with h as just being a variable, right? That was the equation we ended up with. 5 plus h cubed minus 125 over h. Now we're going to give h a value. Okay, and they do this because it simplifies things to plug in h later. We choose negative 0.01, or we can use positive negative 1. Negative or positive. So this is the preceding interval value, and this is the following interval value. So on our graph now, if here is our point of interest, this equation here is taking these 2 points, and this equation here is taking these 2 points, where the difference between the x values is plus h and minus h. I'm drawing it small because h is such a small value, but you know, if I were to draw it bigger. Right? So a is in the middle, plus h, minus h. They're finding this slope in the preceding interval. They're finding this slope in the following interval. Okay, you can use either one, because what you find out is that your answer is just on either side. Okay, because again, preceding and following. So they take the average of the two and they get the answer, the middle. Okay? So they take this slope and they average them and they get the slope in the middle. Any questions? Yeah.
Why would you do that when in the previous, when we were doing solution A using the centered intervals? Why would we do that when centered intervals took way less time?
Yeah, you're not actually going to do this. You're not going to take the averages. You're just going to use one. As long as h is small enough, you're going to get close enough. Okay, you can imagine if h went to negative 0.000001, this value is going to be 74.99999. You guys get that?
Yeah.
And as h here went to positive 0.0001, this value would be 75.00001.
Yeah.
Okay, I'm just still kind of leading it in with the way the textbook's explaining it. And you guys might think, yo, you know, I get it. This is maybe not necessary, but conceptually, if you guys understand this, it's going to help you guys so much more when you do word problems. You're going to understand what's going on, okay? And what you're actually trying to find. That's what's important, okay? It's great to just be able to use formulas, but if you have a conceptual idea, you'll know if you mess up, right? If it makes sense, if it's positive or negative. These slopes are all negative. We realize that. These slopes are all positive. You know what I mean? Okay, so it is a little bit cumbersome in the way it's explained, but that's the reason we're doing it. Any other questions?
So why is the slopes negative there?
These ones?
Yeah.
Why are they negative?
Yeah.
The slopes? Because they're going down. Negative.
I understand that, but I'm saying if the...
It's just like a random problem I drew.
Oh, okay. I thought I had
No.
I thought I had to do the question.
No, this is just like trying to show it more blown up. Yeah, but sorry if that's misleading. The actual question, you're right. The volume is going up, so it would be, you know, if this is our volume and this is our x, it would be like this. Yeah. Okay? So you're right. The slopes would be positive. Okay. 3. Selecting a strategy to estimate instantaneous rate of change. So we have an oven that heats up from room temperature to 400 Fahrenheit. So there's our time. And there's our temperature going up. Okay, so we have a table of values. Estimate the instantaneous rate of change in temperature at exactly 5 minutes. So please don't tell me, oh, the instantaneous rate of change is 280 degrees Fahrenheit. Well, that's not right. That's the temperature at 5 minutes, not the rate at which the temperature is changing. Okay? So it's not grade 7. I'm not asking you the y coordinate of the x value 5. You won't get part marks for that. Okay, I'm asking you for the slope of the curve at this point. So we can use the intervals between 2 and 8. So these are really bad intervals, right? So you might ask, why would we do this? Well, they're evenly separated over 5, so might give us kind of a big range. Sorry? Yeah, 4 and 6 would make the most sense because they're the intervals that we have the values right away. So let's see if they do that. Yeah, see, they eventually go down to 4 and 6. Okay? Yes, definitely you would skip those other ones, right? You wouldn't progressively. They're just showing you the value is coming down to 30. So at this interval around 5 minutes, it gets smaller. It appears that the average rate of change in temperature of the oven gets closer to about 30. The next one, and we all hate technology, it says estimate the instantaneous rate of change at exactly 5 minutes using a quadratic model. I would strongly recommend, if you guys don't know how to do this, learn how to do this on your graphing calculator app. It's not hard. You plug in the table of values and you do what's called a quadratic regression, and it'll make a formula for you. And some of you guys might even have a calculator that can do this, and not a graphing calculator because they're not allowed. But you know, some of the Casio, the top calculators, there might be some function like this. It's worth getting familiar with how to do this on an app, especially if you're doing your homework. So you plug in the values in this table, the calculator will give you this formula, and then we can use algebra to calculate the very precise instantaneous rate of change, which happens to be 32. And they used an H value of 0.01, okay? So then they calculated F at 5.01 and F at 4.99. They got their change of F to be 0.64, change of X to be 0.02, and they calculated 32. Okay? Any questions there? So, in summary, it's a long one. Instantaneous rate of change of the dependent variable is the rate at which the dependent variable changes at a specific value of the independent variable. So in other words, slope at point A. I'll say x equals A. Okay, instantaneous slope at point A. The instantaneous rate of change of the dependent variable in a table of values or an equation of the relationship can be estimated using the following methods. So, this is preceding and following, we don't like. This is the centered interval, it's a little bit better, it's the combination of these two. But this is the one we really like. And it's called the difference quotient. So, great communication question on your next test. What is the difference quotient?
Then would we have to write down the formula?
Yes. Difference quotient, just to review, it is okay. And my hope is now that every single one of you in this classroom knows what the A is, knows what the H is, and knows what's happening here, what we're finding. Very, very important that we're finding the slope at A. This is H, this is minus, or A minus H, A plus H over here. Questions? Yeah.
So were you saying earlier that just to plug in one or the other, either the plus 01 or the minus 01, and then use the other value of the just the point of interest, I think that would be.
Yes.
Yeah.
Yeah.
Okay.
Any other questions? Okay, that's it.